APGP. All right. Now, arithmetic and geometric progression as a chapter as a whole, it's a pretty small chapter and pretty straightforward too. And once you just do a bit of questions, right, you will probably be very familiar with it, probably be very comfortable with it. Now, we can break APGP into two subparts: the arithmetic progression, arithmetic progression and geometric progression, right? And let's first look at AP, arithmetic progression. So if I draw a number line, if I draw a number line, and let's say there's a frog at the point one, right? So at t equals 1 second, there's a frog. This is supposed to be a frog at one, at the value one. All right, and after every second, the frog is jumping 2 units to the right. Right, so at t equals 2 seconds, it will be at 3, right? And then another second passes and it jumps 2 more and it ends up at 5 at t equals 3 seconds, right? So 1, 3, 5. This was at t equals 1 second, 2 second, 3 second. And the frog continues to consistently jump 2 seconds to the right. So 1, 3, 5, 7, 9, all the way, right? 7 will be the fourth second, 9 will be the fifth second, and so on. So when you have a series such that you start with some number and then you're consistently adding or subtracting to get the other term, it is what's called an AP, an arithmetic progression. Right? It's a series, and series, by the way, is just a bunch of numbers, really. So this is a series such that it's an arithmetic progression. You start with a number A, right? By convention, we just call the starting number A, and the gap between two numbers, in short, the jump that the frog is making, is what's called D. In this case, it was plus 2, but in general, this is what's called D. So A is my first initial number or my starting point, first number in the series. D is my difference between the two terms. So there is some n plus 1th term. So Tn plus 1 minus Tn, or you could just say Tn minus Tn minus 1. Basically, D is just term minus the previous term. All right. So in APGP, there's just two things to remember. Number one is the term formula. Number two is the sum formula, right? What term formula basically is that it's a formula such that you can calculate the value of the term. So in this particular progression, when the term is 1, the first term, the value is 1. At the second term, the value is 3. At the third term, the value is 5, and so on. So in an AP, in any AP, I can write it as A, comma A plus D, comma A plus D plus D, because after every term there's a plus D that's adding to it, right? So A plus D plus D plus D and so on. And well, this is the same as a plus 2d because multiplication is basically adding the same numbers again. So I can write this as a plus d, a plus 2d, a plus 3d, and so on. Right? This was the first term, this was the second term, third term, fourth term. What you'll realize is that for any nth term, you start with a, and then since you keep on adding d's and the number of d's you add to get to n is n minus 1, so tn is a plus n minus 1 d. This, let me change the color. This is the sum formula. So let's say I've given you this sequence and I ask you, okay, at the 10th second, where is the frog? So your A is 1, your D is plus 2, and I'm asking you what is T10, right? T10. So T10 will basically be what is A? A is 1 plus n minus 1, so 9, and what is D? D is 2. right? So after 10 seconds, it will be at 1 plus 18, which is 19, right? This is your Tn. Next up is your sum formula. Sn, for any Sn, there's actually two formulas. One is n over 2, 2a plus n minus 1 d. This is the first formula, and the second one is n over 2a plus l, where L is basically the last term. In an arithmetic progression, whenever they ask a sum, or basically what Sn means, it means the sum of the first n numbers. So if I say in this particular sequence, what is S3? Well, S3 is just the sum of these three numbers, right? Sum of these three. So S3 is just 1 plus 3 plus 5, which is 9. Okay, so some of the first n numbers you can either find by this formula or this formula, where L is basically the last term. And actually, these both are the same formulas, just stated in another way. So, just to quickly show you, L is basically A plus n minus 1 d, because if you're finding the sum of n numbers, the last term will be n, and we know the way you represent n, the nth term is a plus n minus 1d. So let's rewrite this: n a plus n minus 1 d, all of this over 2. This is just n over 2, 2a plus n minus 1d, so really the same formulas. So let's try to make sense of the sum formula too, like we did for the term formula. So Sn basically means a plus d plus a plus 2d, and all the way till a plus n minus 2d plus a plus n minus 1d, right? Now, of course, I can rewrite this as L too, because L is my last term and L is also a plus n minus 1d. But more importantly, what I can also write for this is L minus d, because if I am on the nth term and I go to the n minus 1th term, I just have to take out 1d from it, right? So if I write Sn as L plus L minus d plus L minus 2d, and all the way till L minus n minus 2d plus L minus n minus 1d. So by just this is you could call it trick by pairing. If we just add these two, so 2Sn, and we know that we can pair these two such that all of after you add them, all you're left with is A and L. So if I take this A and I pair it with this L, it becomes A plus L. And then if I take a plus d and I pair it with L minus d, well, that's just a plus d plus L minus d. So really the d's cancel. I can write this as a plus d. Right? And this goes on for all of them. This the a plus the a plus L will continue n times, right? Because there are n terms. So I can just write this as n times a plus L, because there are n of these adding together. So 2Sn is n plus a is n times a plus L. So Sn will just be n a plus L over 2, and this is our sum formula. And of course, if n over 2 a plus L is true, the other formula has to be true, because they're both basically the same thing. All right, and this is all there is for arithmetic progression. There's not really nothing more to it.